So let's try to go for one particular problem, and it's a very simple problem. So there is an observer, and let's say this is observer, and one source of light moving away from observer with velocity v, and another source of light is moving towards the observer with velocity v, and the frequency of both is nu naught. The frequency with respect to source, let's say S1, and this is frequency with respect to source S2, both is nu naught, and both is moving with velocity or speed v, and they are in the line with the observer. Okay, and the frequency measured by the observer with second and first is basically nu2 and nu1. And if nu2 and nu1 is equal to 7, so you have nu2 by nu1 is equal to 7. This is observed frequency by this particular observer from the source second is nu2, and from the source S1 is nu1 is equal to 7. Then what we have to do? We have to find the velocity v. So this type of question can come into your examination. So how you will proceed? So obviously, what will be your nu2? So this is moving away. Sorry, so nu1 by nu2 is 7. So this is nu1 by nu2 is equal to 7. So this is moving away from this particular observer. So what will be frequency? बताइए क्या होगा frequency? That nu naught 1 minus v upon c 1 plus v upon c. V upon c. Okay. So this is your nu2. What about nu1? This is moving towards but in the line. So what will be this value? So this value is equal to nu naught, and you have 1 plus v upon c upon 1 minus v upon c. And there is one relationship given that there is mu1 by mu2 is equal to 7. So what will happen? So this value is equal to, so mu1 by mu2 is equal to 7. That means we have root under 1 plus v upon c, 1 minus v upon c by root under 1 minus v upon c, 1 plus v upon c. That value is 7. So you can just simplify this thing, and this is wonderfully given by 1 plus v upon c by 1 minus v upon c is equal to 7. And you can solve this particular thing. 1 plus v upon c is equal to 7 minus 7 v upon c. You can add 8 v upon c. You can take it here, and that value is 6. So v is equal to c by 6 by 8 into c. And that value is equal to what?
3 by 4c.
3 by 4c. So that value is 3 by 4c. So this is your very simple question, straightforward question. And this can be, and it was in your paper actually. So you can see, once you understand what is going to happen, you can easily use the formula and you can solve it. Next, let's go for our next problem, which is more interesting than this one. And that is, again, a straightforward problem, but yes, that was interesting. The language is very interesting. So you can just solve this type of problem. Obviously, you have to always take care when your frequency, when your source is approaching to the observer, then observer will find higher frequency, and if source is receding from the observer, then he will find the lower frequency. So this is wonderful problem. So there is a detector, and one nuclear source is moving. So this is some nuclear source is moving with respect to detector, and both are not in line. So this is very interesting. So both are not in line. So obviously this kind of ray will come to the detector, and this is moving with velocity v. So it is given when this source is at the minimum distance of detector. So when source is minimum distance with detector, then frequency is 2 times nu naught. So this is your nu naught. Nu naught is the frequency with respect to source. That means when observer is rest with respect to source, then he will get frequency nu naught. But when it has minimum distance, the minimum distance between detector and source, then he will measure the frequency is 2 nu naught. Then find the value of B. So just a minute. So this will be nu is equal to nu naught 1 minus V square C square. So this will be less. Okay. So that value is nu by 2, nu naught by 2. So this value is nu naught by 2. Then find the value of B. So what is meaning of minimum distance? उस समय क्या होगा, क्या कहानी होगी? Perpendicular. So that means when the source will reach here, this is direction of B and this will be direction of your radiation, and the angle between them is 90 degrees. That means they are talking about the transverse Doppler effect. So nu is equal to what? Nu naught by 2, and this value is nu naught. You are getting 1 minus V square upon C square. Then what is your value? 1 upon 4 is equal to 1 minus V square upon C square. And you can have V is equal to what? Root 3 by 2C. So obviously this should be the less than nu naught when it will come to the transverse. This. Okay. So this type of question can come into your examination, and you can always see what is the situation between detector and source, what is the situation between observer and source, and yes, V is nothing but what? Relative speed. So you have to work out with this type of problem. Okay. So that is just you have, once you know what is the relative speed between observer and source, and you know what is the real angle, and when you are going to use the longitudinal Doppler effect, when you are going to use transverse Doppler effect, then obviously you can do it in a very easy manner, and that is cakewalk for you. So let's try to go for next level of analysis. So we will just try to see that it is not only that position and time have Lorentz transformation. It is not only that your momentum and energy has Lorentz transformation, but there are n number of different physical quantities which has also Lorentz transformation. So here we will just try to go for a very nice information and nice analysis all about the charge density and current density. So what we have also a same type of symmetry between charge density and current density. So there is again a Lorentz transformation for charge density and current density. So what will happen when you have a Lorentz transformation between charge density and current density? Then obviously the charge is related to your electric field and current is related to your magnetic field. So why you have a current density, sorry, you have a one type of transformation between electric field as well as in magnetic field. So this is very interesting. Let's try to analyze all this thing, and we will also learn this thing with the help of different type of problems. Okay, so let's try to go for this. So again, you will see the current is a vector quantity. If I am talking about current density, so they are vector quantity, and charge density is a scalar quantity. So again, what you have C square rho square minus mod j square is equal to c square rho naught square. So again, this c square rho square minus mod j square, where j is nothing but the current density, has a Lorentz invariant. So this is again a Lorentz invariant, and this is known as proper charge. That means when charge is not moving with respect to observer, then you are just going to measure the proper charge. And if this is just going to follow this type of symmetry, then obviously you can write a Lorentz transformation for charge density as well as current density. So let's try to go for a charge density and the Lorentz transformation for charge density and current density. So what we have again S frame, and this S dash frame is moving with respect to S along X direction. So this is my X direction. So deliberately we are taking this is my X direction such that we can write the formula accordingly. Otherwise, you know that your Lorentz transformation will decide what will be the relative speed between S dash and S. So if S dash is moving with respect to S along Y direction, then obviously Lorentz transformation will along Y direction. But here we are just going for the this particular simplistic or trivial conveyance of this particular Lorentz transformation. So what will happen? So from S frame, you have charge density, current density component is Jx, Jy, Jz, and charge density is rho. And with respect to S dash, we have current density component is Jx dash, Jy dash, Jz dash, and this is your rho dash. And what you have basically Jx is equal to Jx dash plus V rho upon root under 1 minus V square upon C square. Jy has not any effect. Jz has also not any effect. But yes, there is a charge density. This rho can be written as rho dash plus V Jx dash upon C square, and that value is 1 minus V square upon C square. So this is your Lorentz transformation for charge density and current density. And you can use it, and you will find that with respect to one particular reference frame, you can have only charge density, but there is not any current density. But if you will go for the another reference, you will find that there is current density also. And once there is current density, you have magnetic field, and all about this type of thing is there. So let's straightforward go to one basic problem. है ना? Okay, clear है ये? So let's try to go for one very nice problem, and this is one of the analysis also. This is also theoretical analysis also. So let's see what is going to happen. And I am following the book that is Resnick, the book of Resnick of the relativistic mechanics. So if you want, you can just consult that book. Very nice book for relativity. So you can just go for this. So let's try to go for a very nice case study when you have current carrying wire. And let's say this wire is rest with respect to S frame. And the number density of the charged particle, number density is N. And what will happen? You can apply some voltage into this particular wire. Then what will happen? This positively charged will remain there, and negatively charged will move with respect to positive charge, isn't it? With the some velocity that is also known as what? Drift velocity, with velocity u. So negative charge with moving with respect to this particular wire is velocity u. But positive charge is just going to be rest. So let's try to figure out what is your current density, what is your charge density for positive charge and negative charge, and for the combined system with respect to S. And then there is another reference frame, that is S dash, which is moving with respect to S with velocity V. So this U is your drift velocity. That means when you are sitting on a wire or you are sitting on a positive charge, and you can see this electron is moving with velocity U, and then your current have obviously in opposite direction. Okay, you can measure the direction of current with the opposite direction of the electron. So this is very fundamental thing. You know all this thing. So let's try to go for this. So first we have two type of charge. One is positive charge, another is negative charge. So what will be rho plus? What will be rho plus? N into E. Yes. N is the number density. E is the charge. Is the charge of the positive charge. So that will be rho plus is Ne. What will be your rho minus? Minus N into E. Everyone, and we are measuring it from which frame? We are measuring it from S frame. Now, what will be J plus or Jx plus? So this is along x-axis. I am just neglecting all the y component. What will be your J plus? बताइए क्या होगा? 0. And what will be your J minus? Minus NEU. This will be your J minus. Everyone is comfortable up to this? क्योंकि ये इस पर ही रहोगे तभी हम लोग आगे बढ़ सकते हैं. Yes?
Yes, sir.
है ना? So that value is N minus NEU. Now, what will be your total charge? The combined charge is nothing. That value is rho plus rho minus. So that value is equal to 0. Yes? Are you getting my point? Rho plus and rho minus is equal to 0. And you know that this wire is, so why this wire is what? Electrically neutral with respect to S frame. And what about your complete current density J? You have Jx plus Jx minus, and this is your Jx minus actually. So what will be this value? Minus NEU. So you have current in an opposite direction of U. Okay, so this is very fundamental. The +2 level information we are just talking about. Now let's try to find all this charge density and current density with respect to S dash frame. Let's say what is going to happen with respect to S dash frame. So what will be your rho plus dash? So rho plus dash can be written as rho plus minus V Jx plus, because we are talking about plus charge, so we are just going for the plus charge here. So that value is equal to pi c square by root under 1 minus V square upon c square. And this S dash is moving with respect to S or moving with respect to this particular wire with velocity V. So what will be this value? That value is equal to what? Ne, and this Jx plus is 0. So you have 1 minus V square upon C square. So this will be rho plus dash. Now you can see the charge density is going to increase. है ना? Charge density क्या हो गया? Increase कर रहा है. Because this is Ne and this is more than Ne. Why it is going to happen? That this charge density is going to increase. ऐसा क्यों हो रहा है? Why it is going to happen that charge density is going to increase? Anyone? बताओ. Very simple logic. What will happen? The length contraction is there. If you have this particular length, and if you are going to measure this particular length with respect to S dash, then this is going to be contracted. So number of charge will be in the less length. So obviously the density will increase, isn't it?
Yes, sir.
Yes,
है
sir.
ना? So why you have this type of situation? So this is very logical also. The density is, please mind it, charge will remain same. The density is going to change. This is very fundamental. और एक बार किसी एग्जाम में क्वेश्चन आया हुआ था. Your density will going to change, but charge will remain same. Don't worry. But number of charge per unit length, number of charge per unit area is going to change. But here I am just talking about length because we have wire something this, and obviously you have length contraction along only in one direction, and that will affect it into your particularly area or volume also. Okay, so let's go for next thing. That value is rho minus dash. What will be this value? Rho minus v jx minus upon c square root under 1 minus v square upon c square. So what is your rho minus? Minus ne minus v, and what will be your jx minus? Jx minus क्या है? Minus ne u upon c square, and here you have 1 minus v square upon c square. You can take minus ne outside, and you have 1 plus uv upon c square root under 1 minus v square upon c square. ठीक है ना? Sorry, गलत लिखा हूं क्या? So minus that will be minus sign will be there. Okay, so this will be minus sign is there. So what will, and this will be your rho minus dash. What will be your total charge? The total charge density, you can just add it, and then what you will get? You have total charge rho is equal to rho dash is equal to rho plus dash plus rho minus dash. So this value is ne 1 minus, and you can just take this particular minus sign will be there. So this component is going to cancel out, and what you will get? आपको क्या मिलेगा? Minus nuv upon, or e is also there. So ne uv upon c square root under 1 minus v square upon c square. This will be your rho minus. Okay. So ये सब एग्जाम में डायरेक्ट क्वेश्चन आ सकते हैं, अभी तक आए नहीं हैं, और सो आप प्लीज उसके लिए तैयार रहोगे. ठीक है?
माइनस साइन क्या?
प्लस में आएगा.
Plus sign will be there. Plus sign will be there. So minus minus plus sign is there. Okay, good. So that value is ne uv by c square. So you have this particular charge density. Okay, the combined charge density is this one. Let's go for current. Let's see what is going to happen this particular current. यहाँ तक clear है ना? ये एग्जाम में आ सकता है, प्लीज. ग्रिफिथ में ये डायरेक्ट फॉर्मूला यूज किया गया है, बट वी आर जस्ट डिराइविंग दिस थिंग. ओके, हम लोग इसको डिराइव कर रहे हैं, एंड डोंट थिंक दिस इज प्रॉब्लम, दिस इज थ्योरी ऑल्सो. ओके, लेट्स ट्राई टू गो फॉर अ करंट डेंसिटी. करंट डेंसिटी क्या क्या मिला था एक बार मुझे बता दो. jx माइनस क्या मिला था? 0, है ना?
jx plus 0.
jx plus is equal to 0, and jx minus is equal to what? Minus neu, है ना? Okay, so let's try to go for jx plus dash. बताइए क्या होगा फॉर्मूला? jx minus b rho upon root under jx plus 1 minus v square upon c square. So jx plus is equal to 0, and this value is equal to minus v, and this is rho plus, na? So rho plus. So what is your rho plus?
Ne.
Ne. And that value is 1 minus v square upon c square. Okay, let's go for jx minus. So that is jx minus dash actually. So jx minus v rho minus root under 1 minus v square upon c square. So what you will get? So jx minus is equal to what? Minus neu, and rho minus is basically minus nev. यही होगा ना? And you have root under 1 minus v square upon c square. What you have? Ne, and you have v minus u, and that value is equal to 1 minus v square upon c square. So you can see this type of situation is there. And what will be your combined current? If you will go for your combined current, Jx is equal to Jx plus Jx minus, then anything is going to cancel out? Yes.
NEV वाला term.
NEV वाला part cancel out हो रहा है, और क्या मिल रहा है आपको? Minus NEU, and you have 1 minus v square upon c square, isn't it? So this will be your combined current. So this type of thing you can easily derive if you have, and always try to think जिस पार्टिकल का आप चार्ज डेंसिटी, जिस तरह के जिस पार्टिकल नहीं कहूंगा, सपोज आप प्लस के लिए चार्ज डेंसिटी ले रहे हो तो प्लस के लिए ही करंट डेंसिटी लोगे. ओके, यू विल जस्ट थिंक दिस ऑल थिंग एज टू डिफरेंट प्रॉब्लम. एक प्लस वाले के लिए सारी कहानी अलग चल रही है और एक माइनस वाले के लिए सारी कहानी अलग चल रही है, और कंप्लीट वायर के लिए देख रहे हो, देन यू हैव टू जस्ट कंबाइन प्लस एंड माइनस टुगेदर एंड यू विल गेट this sort of information. Okay, now if you understand this thing, then obviously you can see from one particular frame, if you have current density and there is not any, if with one particular frame you have only charge density, there is not any current density, then there may be possible from another frame there may be charge density as well as current density, and for that you will have different electric field and magnetic field from two different frames. So let's try to do one basic problem. This is one of the very fundamental and one of my favorite problem. So let's try to do this thing from the fundamental knowledge of electrostat first, and then we will find this all thing with the help of Lorentz transformation of electric field and magnetic field, and we will just try to see what will be, is that our result is same or not. So this is very interesting exercise to build up the concept. So हम लोग चले आगे, है ना? Let's try to go for this. And please have a patience. आज हम लोग इस टॉपिक को फिनिश करेंगे, है ना? So maybe 10 minute extra लगे तो आप please patience रखना, ठीक है? Let's say go for this one. So there is a S dash frame and there is an infinite charge, line of charge. आपने पढ़ा होगा इस क्वेश्चन को, इलेक्ट्रोस्टैट में किया होगा. With and this line of charge have current density, charge density lambda naught, charge per unit length is lambda naught, and which is rest with respect to S dash, and S dash is moving with respect to S with velocity v. So what we have to do? First we have to find the electric field with respect to S dash, the magnetic field with respect to S dash, and then we have to again find the electric field with respect to S, and then we have to find magnetic field with respect to S. Okay, and we will just use the fundamental theory. We will just try to use the fundamental theory of electromagnetic. Okay, so and electric field at which point? Obviously at the A distance, at P point along y-axis. Okay. And the magnetic field is also there. And there is only this charge density is there. Lambda naught is the charge, and this is infinitely long wire. Okay. So now what is your electric field? So your electric field has three components. So Ex is equal to 0. I can say this is my x direction. So this is your x direction. So Ex dash is equal to 0 because it is from the S dash frame. So I can write Ex dash is equal to 0. What will be your Ey dash? बताइए. Just electrostat में जो पढ़े हो मैं उसी की बात कर रहा हूं. What will be your Ey dash?
Lambda upon 2 pi.
Very good. Lambda naught
Yep.
upon 2 pi epsilon naught A. ठीक है? Everyone is comfortable? And what about your Ez dash? That value is again 0. Okay. And your magnetic field is obviously 0 because there is not any current is going to flow along x-axis. So this is over. And you have done this thing since your +2 level. Okay. You have done all these things from your +2 level. Let's try to go for with respect to S. So with respect to S, this charge is going to move with velocity v. Then what will be charge density? Lambda is equal to lambda dash plus v jx dash upon c square root under 1 minus v square upon c square. What is your lambda dash? Lambda naught. This is 1 minus v square c square. There is not any current with respect to S dash, so this will be 0. So this is your new charge density. Okay. So this is your new charge density. And obviously this charge density will be increased due to this length contraction. And let's try to go for electric field. So again, your Ex is equal to 0. But what about your Ey? And this length is not going to contract along y direction. So this length we can same from the S dash as well as S. So what is your Ey? क्या हो जाएगा? Lambda upon 2 pi epsilon naught A, and that value is equal to lambda upon 2 pi epsilon naught A root under 1 minus v square upon c square. Clear है ये? And similarly, your Ez is equal to 0. Now, let's try to calculate the magnetic field also. Okay. What is going to happen? Magnetic field from the S frame. यहाँ तक clear है ना? So I am just going to calculate here. So obviously, what will be your current density? Your current density is Jx dash plus rho dash v upon c square root under 1 minus v square upon c square. And this Jx dash is equal to 0, but rho dash is equal to lambda. So you have lambda naught v upon c square 1 minus v square upon c square. Okay. And सही लिखा हो ना? Yes. Now,
Yes.
what will be your? Now there is current flowing in this wire with respect to S, and this is the value of this particular current. Okay. So now, what is your magnetic field? Magnetic field किस direction में होगा? What is your magnetic field? Px is equal to what? 0. Py is equal to 0. But you have Bz, and you will use the Ampere's law. And what is this Ampere's law? Mu naught I. ये होता है ना? Mu naught I upon 2 pi A. Are you people know this thing? जानते हो ना?
Yes, sir.
है ना? And here, hence it is just in a wire, I can replace my current to current density, so there is not any problem. So you have mu naught lambda naught V upon C square root under 1 minus V square upon C square. So this is your basically magnetic field, and that will be in k direction. Now we are just using our first principle and we get this answer. Note down this answer, and now what we will do, we will use a symmetry of electric field and magnetic field, and then we will try to figure it out the same answer. This is fundamental. We know this solution. If this is my electric field and this is my magnetic field, is that the transformation of electric field and magnetic field will give the same answer or different answer? We have to just try to figure out. मैंने कुछ गलत लिखा है यहाँ पर ना, just a minute. That will be not c square. Sorry, that will be not jx plus rho v, है ना? There will be not c square. बार बार गलती होता है ये. Everyone is comfortable right now? फॉर्मूला ठीक है ना?
Yes, sir.
प्लीज सी स्क्वायर नहीं होगा, मैंने गलत लिखा था, ठीक है? सो प्लीज करेक्ट द फॉर्मूला. कुछ लेट्स ट्राई टू गो फॉर दिस. सो what will happen to the electric field and magnetic field? So if, and you know from the Lenz law and from the Faraday law, if you have moving charge, then there is electric field and there is magnetic field, and electric field and magnetic field is associated to each other with some beautiful equation that is known as what? Maxwell equation. Okay. And obviously, you know that Lenz law and Faraday law just attach electric field to magnetic field and magnetic field to electric field. So there is not any problem. And from that symmetry, we have also a one very nice invariance law in electrodynamics. And that invariance law is basically, and that invariance law is basically E dot B is invariant under Lorentz transformation as well as you have mod E square minus C square mod B square is also invariant under Lorentz transformation. So you have these two information and you can prove it also, but I am not going into this particular derivation part. I am just using it as a basically facts. Okay. So if you have this electric field and magnetic field, and C is nothing but the speed of light, then this quantity is also Lorentz invariant. And you have the transformation between electric and magnetic field. And what is this transformation? I am just talking about this symmetry where S is moving with respect, S dash is moving with respect to S with velocity V in I cap direction. So I am using this symmetry because obviously X, Y, Z component has very important role. So if I have this symmetry, then I have transformation between electric field and magnetic field. We have Ex is equal to Ex dash. Obviously, Ex, Ey, Ez from the S frame, Ex dash, Ey dash, Ez dash from the S dash frame. And same type you have for the magnetic field. So what is this particular transformation? Ex is equal to Ex dash and Ey is equal to gamma time Ey dash plus V Bz dash. And you have Ez is equal to gamma time Ez dash minus V By dash. And obviously you have this cross product term. B E cross B is some K vector, and that it will just also going to fulfill all this story. So why this type of equation is coming there. And similarly, you have transformation of magnetic field. So I am using this space. यहाँ पर हो जाएगा? Yes. What you have? Bx is equal to Px dash Py is equal to Py dash, and you can write gamma time Py dash minus minus V upon C square E Z dash, and your Pz is equal to gamma time Pz dash plus V upon C square E Y dash. Okay. So आपको अब इसे याद ही रखना पड़ेगा. There is not any thing that you cannot remember, because इसे derive करना एग्जाम में बहुत ही मुश्किल होगा. So how you will remember? Don't worry. S dash is moving along S direction, so there is not any transformation for X. Remember only one thing. EY, EY dash, EZ, EZ dash. You have plus sign with VZ dash here. Okay, because due to this is for the due to cross product, B cross E type thing is there. So you have this BZ dash, and once you have BZ dash here, then obviously in the magnetic field, here is plus, By has negative, and BZ has positive. So you can easily remember this particular symmetry. Now, using this symmetry, let us try to figure it out. Whatever we have calculated in the last problem is correct or not. Okay, let's try to calculate this particular thing. So what we have information from the last problem, in our last problem, what is my Ex dash की वैल्यू क्या थी? Sorry, Ex की वैल्यू क्या थी? Ex dash is equal to 0. Ey dash is equal to lambda naught upon 2 pi epsilon naught a. And what about your Ez dash? That is 0. And same time, you have Px dash is equal to 0. Py dash is equal to 0. Pz dash is equal to 0. So we have this information. Let us use this symmetry and check whether we have done the correct calculation or not. Because we have just used first principle there. And we can counter that thing. We can critically analyze whether we are doing the correct calculation or we are doing the wrong calculation. So let's try to go for this. So what will be your Ex? That value is 0. What will be your Ey? Bz dash is 0, and that value is equal to gamma time Ey dash is lambda naught upon 2 pi epsilon naught a, and this value is equal to lambda naught upon 2 pi epsilon naught a 1 minus v square c square. So now you can see that is the exactly same answer or different answer. देखो लास्ट प्रॉब्लम में सेम है या डिफरेंट है? सेम है.
Same.
And what about Ez? That value is also 0. You can put it there. Ez dash By dash, that value is 0. Let's try to calculate your magnetic field part. Okay. So what about your Bx? 0. What about your By? By dash is equal to 0. Ez dash is equal to 0. So this is also 0. What about your Bz? देखिए तो क्या आ रहा है? Gamma time Bz dash is 0. V upon C square Ey dash is lambda naught 2 pi epsilon naught a. Yes. And this value can be written as V lambda naught upon C square 2 pi epsilon naught a root under 1 minus V square upon C square. And what is your C square? 1 upon C square can be written as mu naught epsilon naught. ये तो पता है ना? So you can have, so this epsilon naught will cancel out. So you have mu naught B lambda naught upon 2 pi epsilon naught a 1 minus V square upon C square, and this is nothing but Bz. Same or different? जस्ट चेक इट, सेम और डिफरेंट। देखो तो क्या आ रहा है, सेम है या डिफरेंट है? सेम आ रहा है ना? सो यू कैन सी, सो दिस इज वेरी इंटरेस्टिंग टूल। अब आपने कई अपने सिस्टम की इलेक्ट्रिक फील्ड, मैग्नेटिक फील्ड निकाल के रखा हुआ है, लेकिन आपने किस फ्रेम में निकाला है? उस फ्रेम में जिसमें वो सिस्टम पूरी की पूरी तरह से रेस्ट है। अब आपके एग्जाम में जो भी आपने इलेक्ट्रोस्टैट में प्रॉब्लम किए हैं, उसी प्रॉब्लम को आपको यहां पर पूछा जाएगा कि भाई दूसरे फ्रेम के रेस्पेक्ट में वो क्या होगा। या तो मैंने जस्ट एक लाइन, चार्ज ऑफ लाइन के लिए किया है, उसी तरह से आप शीट के लिए बात कर सकते हो और बाकी चीजों के लिए भी बात कर सकते हो। बट ऑलवेज ट्राई टू रिमेंबर दिस कॉन्सेप्ट ऑफ लॉरेंस ट्रांसफॉर्मेशन। सम टाइम मे बी यू हैव टू यूज लेंथ कॉन्ट्रैक्शन ऑल्सो, इजंट इट? ये सारी चीजें आपको ध्यान में देने की जरूरत होगी, बट फंडामेंटल इज दैट once you know the electric field and magnetic field from one particular inertial frame, you can easily find the electric field and magnetic field from another particular inertial frame in a very nice manner. Okay, so this is very fundamental. Let's try to go for one more problem. yahan tak clear hai na?
Yes, sir.
और एग्जाम में आएंगे क्वेश्चन, प्लीज जो भी लास्ट वाले पार्ट होते हैं, एक्चुअली प्रॉब्लम ये है कि लास्ट वाले पार्ट सबसे लास्ट में आते हैं, शुरू में नहीं आ सकते, है ना? सो लेकिन उससे क्वेश्चंस जरूर आते हैं, और उससे जो भी क्वेश्चंस आते हैं दे आर वेरी फंडामेंटल एंड वेरी स्ट्रेट फॉरवर्ड क्वेश्चन। ओनली इफ यू नो द कॉन्सेप्ट एंड यू नो द basic formula, you can apply it and you will get 5 marks. Okay, so never skip this type of question. Chalo. So let's go for one problem that was came in your exam also. So let's try to do this one. So this is very nice problem. So from one frame you have electric field component, and that is alpha 0 and 0, that is 3 component, alpha 0 0, and magnetic field vector is basically given as alpha 0 to alpha. From one frame, let's say any frame, that is inertial frame actually, and from the another frame you have electric field vector as E x dash alpha 0, and magnetic field is alpha by dash alpha. So this is your electric field and magnetic field. What you have to do, you have to just calculate value of Ex dash and By dash in term of alpha. So this is one of the very fundamental thing. Okay, so you have to just calculate this one. So obviously 2 unknowns, so how many equation you have to write? 2 equation. So obviously you know that E dot B is invariant. That means E dash dot B dash. And let's say this is from S frame, this is from S dash frame. This is S, and S dash is your own prerequisite. So what is E dot B? Alpha square, है ना? This and this will 0. So this is alpha square. What is your E dash dot B dash? Alpha Ex dash plus alpha By dash plus 0. So you have one equation, Ex dash plus By dash is equal to alpha. This is one equation. And what is your second invariant law? So that is E square, and here you have to take C is equal to 1. Okay, that is also given in problem. So E square, C square, B square is also invariant. That means, and we are talking about the mod value. Okay, so always take care of this thing. So you have E dash square minus C square, B dash square. Okay, so you have to just, and C is equal to 1 you can take. What is your E square? Is alpha square. What is your B mod B square? Is alpha square plus 4 alpha square. That is what? 5 alpha square. Okay. What is your E dash square? So that value is equal to EX square plus alpha square minus, this is your alpha square plus BY square plus alpha square. दिखाई दे रहा है क्या, या कुछ कैंसिल तो नहीं हुआ? ओके, ठीक. Okay, so what is this equation? So this is minus 4 alpha square, and this value is equal to 1 alpha square. 1 alpha square is cancel out. So we have EX square, or EX dash square actually, EX dash square minus BY square and minus alpha square. And what you have? You have EX dash square minus BY dash square is equal to minus 3 alpha square. And you can again write this particular thing, EX dash plus, sorry, and minus BY dash into EX dash plus BY dash is equal to minus 3 alpha square. And this thing is nothing but alpha. So you have two equations. The second equation is EX dash minus BY dash is equal to minus 3 alpha. And once you will add it, and again you will subtract it, you will get this value of EX dash. क्या हो जाएगा ये EX dash की value? When you are going to add it, क्या हो जाएगा ये? 2EX dash is equal to 2 alpha, minus 2 alpha, isn't it?
Minus alpha.
Hmm?
X dash is equal to
EX dash is equal to minus alpha. And what about your BY dash? 2 alpha. 2 alpha. So this will be your answer. Okay. So you can easily use this formula and you can work with this type of problem. है ना? So कई बार ऐसा आया है कि जस्ट इसी से काम चल गया हो, कई बार ऐसा आया है कि जस्ट आपको दोनों का ही यूज करना हो. सो मैंने वैसा प्रॉब्लम लिया है जिसमें आपको दोनों का ही यूज करना है. ठीक है. सो दिस इज फंडामेंटल ऑफ इलेक्ट्रोडायनेमिक्स, रिलेटिविस्टिक इलेक्ट्रोडायनेमिक्स. ये आगे जाकर के बिल्कुल एक नई दुनिया में चला जाता है. सो हम लोग वहां तक तो नहीं जाएंगे, बट वंस यू नो ऑल दिस बेसिक कॉन्सेप्ट, आप नेक्स्ट लेवल पर जब अपने रिसर्च लेवल पर जाते हो तो वहां पर आप काम कर सकते हो. बट यू नो ऑल द फंडामेंटल्स एंड ऑल दिस थिंग. सो दिस इज ऑल अबाउट फ्रॉम माई साइड. सो एक और क्वेश्चन देखते हैं. जस्ट आई एम जस्ट गिविंग यू हिंट एक्चुअली. वेरी फंडामेंटल, वेरी फंडामेंटल. समटाइम इस तरह के भी प्रॉब्लम आ सकते हैं एग्जाम में. सपोज देयर इज अ चार्ज Q is there, and at the R distance, what will be electric field? Suppose this is from S dash frame or S frame. What will be your electric field? क्या होगा?
R square.
Q into R by 4 pi epsilon naught mod R cube. यही होगा ना? मैं वेक्टर के टर्म में लिख रहा हूं. ओके. सो ये हमने किस फ्रेम से देखा है? लेट्स से दिस इज फ्रॉम एस फ्रेम, और यही एस डैश फ्रेम से क्या हो जाएगा? क्यू आर डैश 4 पाई एप्सिलॉन नॉट आर डैश टू द पावर क्यूब, इजंट इट? और आप चाहो तो इन दोनों को सेम एक्स के टर्म में लिख सकते हो. सो व्हाट विल बी दिस? क्यू एक्स डैश आई कैप plus y dash j cap plus z dash k cap by epsilon is also there. Four pi epsilon naught x dash square plus y dash square plus z dash square 3 है ना, that is 3/2 actually. क्लियर है ये? नाउ अब इसे आप x के फॉर्म में लिखोगे तो कैसे लिखोगे? हाउ यू विल राइट दिस थिंग इन फॉर्म ऑफ x? दिस इज इलेक्ट्रिक फील्ड E dash को, दिस इज इलेक्ट्रिक फील्ड E dash को s के फॉर्म में लिखेंगे तो कैसे लिखेंगे जरा बताओ? So this x dash can be written as what? X minus vt into gamma, isn't it? I cap, y will be remain same, z will be remain same, and you have 4 pi epsilon naught. What will be your x dash square? X minus vt into gamma square plus y square plus z square to the power 3/2. So what will happen? From s dash frame, this is function of time, और वो टाइम के साथ आपको देख रहे हो कि पूरी की पूरी इलेक्ट्रिक फील्ड टाइम के साथ चेंज कर रही है, एंड यू कैन हैव अ एंटायरली डिफरेंट फिनोमेना, है ना? टाइम किस पर डिपेंडेंट हो रहा है आपका इलेक्ट्रिक फील्ड? आप इस पॉइंट पर आफ्टर टाइम t देख रहे हो, बिकॉज t इज इक्वल टू 0 is the same thing. So t is equal to 0, both are going to coincide. But after time t, when s dash is moving with respect to s after some distance, then you have this sort of information. Clear है ना? So इस तरह के बहुत फंडामेंटल क्वेश्चंस भी आपके एग्जाम में आए हुए हैं. किसी एक फ्रेम से इलेक्ट्रिक फील्ड दे दिया, दूसरे फ्रेम से इलेक्ट्रिक फील्ड कैसे चेंज होगा? इलेक्ट्रिक फील्ड इज जस्ट अ फंक्शन ऑफ पोजीशन, और वो पोजीशन का लॉरेंस ट्रांसफॉर्मेशन आपको पता है, और आप उसको इजिली इनकलकुलेट कर सकते हो अपनी कैलकुलेशन में. ओके, सो दिस इज फ्रॉम माय साइड ऑफ little bit, not very deeply, but I am agreed this is a fundamental of relativistic electrodynamics, 4 vectors, Doppler effect, but at least it will help you to solve 2 to 3 problem from last 2 and 3 classes. Okay, so just do it very fundamentally. I will just give you some reading material also, so you can just read it also, such that you can have some intuition also. Otherwise, this is more than enough for your at least CSIR examination. Okay, so I am just going to stop this class here. Thank you everyone, and all the best for your exam. ठीक है?
Thank you, sir.
Thank you.
Thank you.